All right, hello everyone. Welcome to Teal Tech Tips and Tricks with T4. Today we have Maggie with us. Maggie, can you hear me okay?
I can.
Okay, perfect. So welcome everyone. The purpose of this series is to extend our mission to educating the digital forensic community online. My name is Kent and I am the coordinator of this project, and today's topic is how to validate a SQLite record by manually decoding it in HEX. Presentation will be about 20 minutes and we'll have a Q&A afterwards. There will be a recording afterwards sent to everyone in the email if you registered for this session. As you can see, we're on Zoom and everyone will be muted, so we don't have to deal with managing everyone's audio. You can ask questions or make comments on the side. We'll make sure that all the questions are answered in the end. If Maggie is speaking and there's a question that relates to the context, I will interject if she doesn't catch it. And yes, okay. Thank you. Without further ado, I'd like to introduce Maggie.
Hi, everybody. Welcome to Tips and Tricks, Teal Technologies Tips and Tricks. I was asked to do another webinar, and I thought that what a great idea it would be to build off of the previous SQLite presentation that I did.
Yeah, Maggie, this is your third presentation. Thanks for doing this.
Yeah, no problem. I'm glad I could be of assistance. So what I wanted to talk about was validating an SQLite record in HEX. And I talked about the Pokemon Pokédex database from GitHub. And so I'm going to use that same database to explain how to validate the record in HEX and break down the SQLite structure. So I need to give my caution warning ahead of time that this presentation is like on the extreme geekiness level. So if I lose anybody along the way, I do apologize. This is a portion that we teach in our SQLite forensics class through Teal Technologies, and this is just a snippet of what we go over. So one of the basic key points that I want to get across is how important this structure of SQLite actually is. So the goal for today is going to be to validate the existence of a record and decode it in HEX. And we're going to use the select statement that you see up on the screen, which is going to give us one row ID from the abilities table, and that ability is going to be levitate. So when you look at that in SQLite Forensic Browser, it's going to pull out an ID, an identifier, and a generation underscore ID. And those are going to be the columns that we're going to be looking at. And the data is going to be an ID of 26, an identifier of levitate, and the generation underscore ID as 3. So we want to find that record of 26, levitate, and 3 within our database. So assuming that you had some type of a phone extraction or a data extraction from some type of a device, and you get an automated report or some type of a report that you've generated, you're going to have to validate said record. So assuming that this is a record that you have already recovered, we're going to go back in the HEX and find it and validate its existence. So the first thing that we're going to do is we're going to find our abilities table. The way that SQLite creates its databases, it is all based on structure. So if you were to do a little cheat and you were to look for create table and then the name of the table, which in this case is abilities, then you would go to the creation of that table within your database. So if you look over in the ASCII portion related to the HEX, you can see that it says create table abilities, and then you see the actual creation or the foundation of how that database was created with its tables and all of the structure according to how it was created. So you're going to see if your column is an integer, if it's text, and so on. So this is just the basic creation of the abilities table. From here, you're going to go to that same portion in HEX. And because of the structure, we're going to be looking at 1 byte of data, which is that FC. FC is going to tell us the root of the abilities table. That 1 byte is going to give us the page number on where we can find the root of our abilities table. So if you remember when we talked about this a few weeks ago and we were in SQLite Explorer, we were hopping from page to page to page to get through and iterate through our actual database. Here, that 1 byte based on the structure is going to tell us the root page for our abilities table. To be able to find that page, we're going to translate the hex or convert the hex into a decimal, which is 252. So we want to find page 252 in our hex. So we're going to take the page number, we're going to subtract 1, we're going to multiply it by the page size. In this particular case, we're looking at a page size of 1024, and that's going to give us our offset for the beginning of the page that's going to start the root of our abilities table. So we're going to go to offset 257024, and that's going to be the root of our abilities table. So if you look at the top portion of the 257024, this is what's called a leaf table page. And I talked about that a few weeks ago. We're interested in leaf table pages and we're interested in interior table tree pages. So this is a leaf, this is an interior table tree page. This interior table tree page has a header of 12 bytes, and that's what you're going to see in red. So the first 12 bytes are carved out in red or highlighted in red. And what's of interest to us is the 0004, and then those last 4 bytes of 000004ED. So the 0004 is going to tell us any of the cell pointer arrays that are going to make up our child pages from here. So if you remember, it works on a B tree, and we're going to have parent and child pages. So our interior table tree page is going to be a parent page for the child pages. So we're going to be looking for 4 pages that are going to be left child pages, and then the 000004ED is what's called our rightmost child page. So if you translate the hex into decimal, we're looking at 5 child pages that are going to branch off from this one root page, or the root of our root of our abilities table. We're going to be looking at 1257, 1258, 1259, 1260, and 1261. So we're going to go and take that very first one that's highlighted in blue, which is going to be our 03FB. So immediately following our 12 byte header, which is highlighted in red, we are going to carve 4 byte pairs that make up those 4 left child pages. And the very first one is highlighted in bold in blue, and that's going to be 03FB. So I want to jump to that page. So I'm going to go to page 1257, which is going to be the next page that's going to tell me where to go in this database, because it's always structured where we have to complete step A to go to step B to go to step C and so on. So now that we have decoded our header and our byte pairs, we can now go to page 1257, which is going to be at offset 1,286,144. Well, how did we get that? Well, we took 1257, which is our page number. We subtract 1, and we multiply it times our page size in bytes, which is 1,024, to equal 1286144. How did we get that page number? Well, the 03FB is going to be a relative offset jump on our page. So if I take 03FB and convert it, it's going to bring us to 1019. 1019 is going to be a relative offset jump on the page. So if you look at the top part where 03FB is converted from hex to decimal, it's going to give us a jump on the page, and that brings us to 000004E9. And then there's a subsequent byte of 36. That is going to be converted from hex to decimal, and that gives us that page of 1257. So just to go back, we need our header of our page. We need to know how many byte pairs to carve out, and we need to convert that first byte pair of 03FB. And then we're going to take the 03FB, convert that to 1019. That's going to be a jump on our page. So it's never going to be more than the page size. So it should never exceed the 1024. And we are then going to go to that offset, carve out 4 bytes. Why 4 bytes? Because that's just the way that SQLite is structured. That's one of the rules, where you have to carve it out for 4 bytes and then convert it to get 1257. And then 1257 is going to be our page size, or I'm sorry, our page number, and our page number subtracted by 1 times 1024 gives us our offset. So there is a link. There's a question about how to get to the GitHub link for this database. I will get that. I don't have that with me off the top of my head, but I will get you this database, or we'll either send you the database or we'll get you a link to the database. So yes, we will get that for you. So it's a little confusing about all the jumps, but basically what I want to get across is that in order to follow the structure of SQLite, you have to go from step A to step B to step C. So the reason that this makes it so difficult is if you miscalculate any of your conversions, then you could be on the wrong page or you could be on the wrong record. So now we found our page. We're going to go to offset 1286144. So I have this in the presentation just so that you can look at the conversion of a variable length integer. I'm not really going to talk about it in the presentation because it would really get into the weeds, but I put it in here in case anybody wants any reference on how I convert a variable length integer. I can go over that after as well. So once I get to a leaf table tree page within my abilities table, I'm going to be looking at some key points. I'm going to be looking at the page header, the cell pointer array, the record header, the total payload, the row ID, the record length, the serial type, and the record data. I need to figure out all of this information in order to be able to decode my record manually. So the first thing that we're going to do is the page header. Since we're on a leaf table tree page, and we know that we're on a leaf table tree page because it's a 0D page. If you look at that very first byte, 0D represents a leaf table tree page. I'm going to go to the 0036, and that's going to tell me how many byte pairs if you convert the 0036 from hex to decimal, it's going to be 54 byte pairs. So that highlighted in the blue is immediately following our header, 54 byte pairs. So each one of those byte pairs make up our cell pointer array. Our cell pointer array is going to give us all of the relative byte jumps on this page that are going to give us record data. So on this page is going to be 54 active records within the database. So I'm going to pick the one, I did this ahead of time so that we could find the correct record. The one that's bolded in blue is 0259. 0259 is going to be the one that we're going to we're going to do our jump. But as an example, I also did the very first one, which is 03F3. So 03F3 would be a relative offset jump of 1011 bytes. And the one that I want to go and work with you in this presentation, it's going to be the 0259, which is going to be a relative offset jump of 601 bytes. So this is a jump from our page identifier, which is going to be the 0D. So if you were to go from 0D and increase your bytes by 601, that's going to give you your relative offset jump on the page, which is going to be 1286144 plus the 601 bytes, which is at an absolute offset of 745. So that is the very beginning of our record header. So now we have to start working from here. And again, based on structure, we know certain things about SQLite. So at that 0D, that's going to be a variable length integer, and it's going to tell us what our total payload is. So our total payload is 0D, or 14 bytes of data. How do we find that? We carve from where our record length is, and that's going to be in a slide or two. So your total payload starts at 14 bytes from your record length. Immediately following your total payload is going to be your row ID. So your row ID is 1A. 1A is a conversion of 26. So our row ID for this record is going to be 26. Immediately following your row ID is going to be your record length. Your record length is 04. So 04, 0D is 13, excuse me. So Jeremy corrected me, 0D is 13, so it's going to be 13 bytes. So 04 is going to be 4 bytes, and 4 bytes is going to be inclusive of that 04. So you're going to carve 4 bytes, including the 04, which is going to give you your record length. So your record length is going to include all of your serial types. Your serial types make up what your actual data is going to be and how you're going to carve it. So this is a little snippet of a graph that is taken from the SQLite.org, or a table that's taken from SQLite.org. SQLite.org breaks down all of your serial types. So again, you have to go to step A, to step B, to step C, and so on. So now that we've done our record length, you take 04, you take the next 3 bytes, because the 4 bytes are included of the 04, and you put those bytes into the serial types chart. So you need to take the hex, convert it into a decimal, and then take that decimal and put it into the chart. So 00 is a null value. 00 converted into decimal is 0, and 0 on the chart is null. So that means that our first column of data is going to be a null column, or a null value. The second column is going to be 1D. 1D is 29. 29 is an odd number. So if you look at the bottom of the chart, you go to odd number greater than or equal to 13. So you take that number, subtract 13, and divide by 2, which is 8. So you have 29 minus 13 divided by 2 is 8 bytes of data. So we are then going to carve 8 bytes of data for the data that's going to be housed in this particular column. Then their next byte is 01. 01 converted from hex to decimal is a 1. If you take 1 and you put it into your serial types chart, a 1 is a fixed value of an 8-bit 2's complement integer. So it's going to be 1 byte of data. So these values, the null, the 8 bytes, and the 1 byte integer or 8-bit 2's complement integer are going to then tell you what you now need to carve. So immediately following your serial types is your data. So then you carve your data representing the colors on the screen here. So 0, 0 represented null. So therefore, you don't carve anything for that value. That's going to be your column 1, which was the ID column. We already figured out what our row ID was. Our row ID was 1A. 1A was 26, so our row ID is row ID number 26. The next column was 1D, which was a conversion of 8 bytes. So immediately following the end of your serial types, you're going to then carve 8 bytes. So if you look, that's going to be the blue. It's going to be the C3, I'm sorry, the 6C, 6C. Oh, I think I have a typo there. Right? My apologies. But it's going to be the 6C, 65, 76, 69, 74, 61, 74, 65, which converted into ASCII is levitate. And then the purple, which is the 0, 1, is going to be your 1 byte integer. So immediately following your blue, you're going to carve for your next byte, which is 0, 3. Hex 0, 3 converts into decimal 3, and therefore the generation underscore ID is 3. So we have just validated the existence of this record, the ID, the identifier, and the generation underscore ID to 26, levitate, and 3 in this record data. So how did I know that ID, identifier, and generation ID were the columns? If you go back to that first page where it says the create the table abilities, this is the standard structure of how SQLite databases are created. So this is going to be a table where it's going to say create table abilities. Then you're going to have an open parenthesis, and it's going to give you the columns, and they're all going to be separated by a column. So I know that the first column is the ID column. The second column is the identifier column. And then the third column is the generation underscore ID column. So if you go back to your screen, you know what the column data means and how to carve it. So this was a very easy, simplistic example to show you how to carve a record in HEX. It can get much more complicated as you have a lot of records. So if you go back to this one screen that has the 54 cell pointer arrays, you would have to go through and do all of the records until you find the record that you're looking for. So it can get very complicated. And we go through this and other examples in our SQLite class. So should you want to get some more practice, then we will be glad to explain this in further detail in one of our SQLite classes. How did I learn all this, and how can you learn all this? 3 different ways. There are some great tutorials online. A lot of the information that you see and how I learned structure and how you can learn structure, it has a very fixed structure. So we're at SQLite version 3. And if you go to SQLite.org, all this information on the structure, the serial types, the cell pointer arrays, it's all listed on SQLite.org. Paul Sanderson wrote a fantastic book on SQLite forensics. It goes into a lot of the detail plus much more that I spoke about today. And we have a SQLite forensics class if you're interested in taking any one of our classes. But the probably one of the best and easiest ways to learn this is through one of our classes, doing some research online, or looking at Paul Sanderson's book, which is absolutely amazing. That is the presentation. I realize that it was extremely technical. I apologize for anybody who was lost on this. This is not easy to do. It is what I call using my everyday forensic math, because you're just constantly making calculations and going from step 1 to step 2, 3, 4 until you get to your record data. So I hope everybody enjoyed the presentation. And if anybody has any questions, please let me know. I'm happy to go back to any of the slides and clarify or answer any questions
thanks,
you have.
Maggie. I thought you did very well. Thank you so much. Someone is asking if you could post the specific Pokedex database that you used.
I can do
don't know
that.
if, sorry, what?
I can do that. I don't remember where it is, but I will find it for you.
Okay. Do you think it'd be best to email it to them after the presentation?
Do you want to send it out when you do the follow-up email with the link, or what do you think? Whatever you think is best. We can do whatever way you think is best.
Yep, that works. So we can get it out this afternoon.
Perfect.
Yeah, and then anyone can be able to follow along with what Maggie did, along with the database files.
Sure, I can do that.
Yeah. Okay. Anyone still waiting on some more questions? Getting a lot of thanks and a lot of great jobs. Let's see. Yeah, I would just like to add that we do have an SQLite online course coming up. It is from August 3rd to August 12th. So it's the second online course that we're having after we just completed our first SQLite course that Maggie taught with Sam Brothers. And so it went very well. It was a success. So we're having another one August 3rd to August 12th. And I would just like to just do a shameless plug and just post a link in the chat so people can learn more. Let's see.
Thank you, everyone, for all the thank yous, by the way. I'm reading all the chats.
Wow, everyone appreciated it so much. Yeah, must have done a really good job. Not many questions. So we'll just wait around for another minute and see if anyone squeezes one in. Let's see. Is the upcoming class limited to law enforcement only? Yes, it is. Sorry, I should have mentioned that before. Let's see, what else? Okay, I think I'm going to wrap it up. Seems if any of you have any questions, you can, of course, reach out to Till Technologies, and we'd love to help you. International law enforcement, I assume. Maggie, would you be able to?
I'm not sure what that means. It's if you're not from the US or Canada and you are active law enforcement, military, or government, or you're a civilian working for a law enforcement or government entity, you are included in what we call LEO restriction. So it doesn't matter if you're from a different country.
Will slides or video be available to review the process? Yes, of course. I will be sending out an email this afternoon. If you don't receive it because of spam filters or you unsubscribed to us before, then just reach out to Till Technologies, info@tilltech, or myself, kent.hoffman@tilltech.com. I can always send you a link to the things that you need. Okay, and very cool. I'd like to wrap it up. Thank you, everyone. Thank you, Maggie.
Thank you.
Yeah, have a great week.
Take care, everyone.